Yo, what's up, Raiden? Hmm? Turn your volume up. Always on your keyboard, Raiden, dude. Gold, I got a study to test for you. Nice, dude. What test do you need to study for, Raiden, dude? What do you need help with, bro? Teach me more about this. Cool. Okay, that's cool. Dude, what is this? Is this the... Give me the RTC stuff, bro. What's up,
Hey,
guys?
Can I send you a picture?
Yes, Raiden. Sorry. Yeah, Jack, you can put it in office hours.
Raiden. Raiden, you sound like a kid now.
No.
I never knew that.
Raiden, also, can you
I
mute
am
yourself, please?
texting.
I did it for you, but can you mute yourself, Raiden, when you're
Make me.
when you're typing? Because otherwise,
Oh,
it's
he
like
said
super
make
annoying.
him.
No, I found my sister's OnlyFans, dude. What? What are you guys posting about?
You found your sister's OnlyFans? What?
Someone said that. Someone said that in the chat. I'm confused. Thank you. Thank you for deleting that. I don't know
Oh,
why.
what's your OnlyFans?
Yeah, I
Tell me
don't
in
know.
Discord.
Yeah, guys, keep the please
Oh,
keep this channel for homework questions.
Yes.
Y'all can post memes anywhere else.
no, I just sent it. I just sent it.
All right,
Dude,
that's a
wait,
picture of
wait.
nachos. All right, great, dude. Nice. I like nachos, but that's not homework. Yeah. Post homework questions, dude. Yes, I am gonna go over your work, Raiden. Let me see what you
Where
have,
does
dude.
it say I found my sister's OnlyFans?
Yeah, what's up, Nick? Good to see you, dude. I don't know. Someone posted a
Twitch
meme.
or
Someone
Discord?
posted a meme or something, which memes are cool, but just like you can
Oh,
post that in the meme
so it
channel,
wasn't actually
please.
her OnlyFans?
Yeah, it's not my sister's OnlyFans, no. Although my sister's talked about like just making like an OnlyFans where like she just like does things with like her feet or something because like apparently like weird creepy dudes pay for that.
You'll hook me up, right?
I'll hook you up, dude. Like not even anything
Yeah, what?
sexual, just like walking around. Apparently, guys will just pay
I have
for
a
that
feet
or
fetish
something.
now.
People are fucking weird.
Oh, damn.
Holomechanical
Dr. Gold, you just made me have a feet fetish.
foot fetish. Yeah. Yeah. All right. Raiden, you here, bro? You here, dude? You want to go over your stuff?
Yes.
Thank you. Nice. Okay, cool. All right, let's see. Ooh, you're doing proofs now. Ooh, this is cool. Yes, you're doing geometry proofs now.
Oh, wait.
Yeah, this is where you have to like who muted Grim? Who muted? Don't mute Grim, guys. Just don't like just blank mute him.
Don't. I did the work, bro.
Okay. What do you need help with here, bro? All of them? Which number, Raiden? Which one do you need help with? You gave me two here. Do you need help with 7 and 8? It's okay, Grim. I unmuted you. Just be chill.
Thank you.
Just yeah.
We're
If
still missing my question from last time.
what was your question? Oh yeah. Can you post a higher resolution of it, dude? I couldn't read it, dude.
No, it's probably because you were Lysic, because it was top tier.
No, it wasn't, dude. Give me a better
Yes,
image
it
of
was. I read it myself.
it. Thank you, Mason. Thank you. Mason's posting stuff. See, you guys post stuff that I can actually fucking read. Thank you. I can read that, Mason. Thank you.
I'm actually like the thing I sent you was actually a star test of before, like last year I think.
Okay.
Topic,
All right, let me start the stream because we got people. All right, welcome everyone to Office Hours. This is the cool stream where I help you out with math and science homework, all for free. And you guys can earn rewards like bond coins and gift cards, all types of fun shit. So hop in the Discord, have some fun. Stick around the Twitch if you want to learn some cool stuff that we're gonna go over. So, Raiden posted the first question. Which involves, this looks like geometry proofs. Okay, cool. So geometry proofs are like where like you have to prove that something is true. It's kind of like trying to convince like your parents to like let you go sleep over or like go to a party or something. You have to be like, well, I did my homework and like,
Dr. Gold, I have a question, but I don't have a picture. You get me?
Okay, that's fine. Can you type it out then? Just type out your question in the office hours.
Okay.
That's fine. You can type it out. But anyways, yeah, proofs. Proofs involve like a series of steps where like you're trying to like prove that like something is true. And in order to do that, you have to like, there are a bunch of little in-between steps that you have to be like, oh, well, if this is true, and if this is true, and if this is true, then this final thing is true. Algebra substitution. Okay, cool. Yeah, I know what that is. Grim, we can go over that. All right, Raiden, you here, bro? Raiden? Okay, cool. Do you need help with number 7? Is that what you need help with?
Nope.
Okay, which one do you need help with?
Just proofs in general.
Well, it looks like you're doing something here. I mean, okay. Do you want me to just go through number 8? Is that what you want for like help?
Sure.
Sure. Okay, cool. All right, here's an example. So proof will always have what we call like a given, which is like they'll say like, well, let's just assume that this is true, And so here they say the given is that JK equals NK. So JK is this side. JK, right? Just kidding, right? It's just like JK is this side and NK is this side. And they say that they are equal to each other, which means they're congruent, which is why they put this line here. Whenever they put like this line on lines, that means that these two lines are congruent. Congruent means that they are the same length, and there's I think they're just the same length. I think that's all you can really say about congruent lines. Okay, A is the midpoint of JN. Okay, cool. That's the midpoint of JN. And they want you to prove that angle JKA is equal to angle NKA. Oh, this is cool. So this is interesting. So here they want you to figure out the statements, and they're giving you the reasons. So like whenever you prove something, you have to say like, this is true, and then you have to say why it's true. So here they have given. So always when you start a proof, you should write down like what given things were already like told to you. So Raiden, what was already told to you in this question number 8? What did they already say to you?
JK equals NK.
Good, thank you. Good. So you can literally, that's what you should do. You should just use to say JK equals NK. Okay, that's given. Okay. All right, good. And then the next thing. So this is interesting because usually they don't give you the reasons here at all. They make you just like, it's always good on the last thing to say like what you're trying to prove. So that's what I would write at the end of the day. You're trying to prove that angle JKA right here is equal to angle NKA. So this is what you're eventually trying to get to. All right. So it's all about finding the in-between steps. So they they hold your hand here a little bit because they tell you what the reasons are, and they just ask you to make like the statement. Like they're giving you the reason, and then you just have to figure out what are you trying to prove there, So the first thing is definition of a midpoint. So they're saying definition of a midpoint. And this is the other thing we had to say that A is the midpoint. That's another given. Midpoint of JN. Okay. So definition of a midpoint. So if we're defining something as a midpoint, what do we know about the midpoint in terms of like a line segment? What does a midpoint do? Drink. Oh, I gotta hydrate now. Okay, thanks guys. Cheers.
What was the question?
What is a midpoint? What does a midpoint do?
The midpoint. Oh, I've looked at this in a long time, bro.
Well, yeah.
What
is a midpoint? What is a midpoint?
It's the middle of the segment.
Good, thank you, dude. It's the middle of a segment, right? Yeah. So if A is the midpoint of this segment JN, you see this, right?
Yeah.
What does that say about, for instance, this segment JA and this segment AN? If A is the midpoint of this whole segment JN, what does that tell us about JN and AN?
And
Uh-huh.
the entire thing.
Yes.
And AN is just a part.
AN's a part of it, right? But a midpoint cuts it into two parts that are equal, is what it is, okay? So if this is the midpoint, right, of this whole thing right in here, JN, that means that AN here is equal to JA, right? So that's where we can put like a double line here. This signifies that this line segment right here is congruent or equal to this line segment. The reason we put two lines is because I already used the single line to say that these two line segments were congruent to each other. So and that's what you write here. You write, okay, the statement is, okay, cool. Well, JA is equal to AN. Okay, cool. And then the next thing they have here is the reflexive property. What's the reflexive property say? Anyone know what the reflexive property
Oh,
is?
it's when two triangles have the same exact.
No, dude, that's CPCTC. What is the reflexive property say?
What?
Huh?
NK equals AK. They
Yeah.
have the same. They're on the same side.
Well,
Oh,
the reflexive property basically says that like I am what I am, right? Like the reflect. It's like have you ever like reflected upon yourself or something? Yes, good.
Nope.
It's like a mirror, Nick. Yeah, very good. It's reflexive. Yeah. We're just saying that like okay, cool. Well, AK is just the same thing as AK, right?
47.
Pardon?
Hmm?
You said something, Raiden. What'd you say?
Nothing.
You said nothing. Okay, cool. All right. AK is AK. That's reflexive. That's just saying that, like, okay, this side, right, this segment right here, is itself. And the reason why why we need that is because we're about to prove that this triangle right here, right, is equal to this triangle. Okay.
Mm-hmm.
And the way you can prove that two triangles are equal or congruent to each other, how can you prove the two triangles are congruent to each other?
What was it called? The 5 acronyms.
5 acronyms.
Five. SSS and all those.
Yeah, SSS. Yeah. So what we're gonna say is that, for instance, so this is why this should be SSS. Okay. Hydrate, dude. Thank you, Tina. Tina's making me drink today a lot. Wow. I drank a lot last night. I really don't want to drink anymore today, but I do want to drink more water. Thank you. Okay. SSS, right? Side. Okay. So what that means is that, okay, if two triangles all have the same sides, then those two triangles are congruent, or those two triangles are the same. Okay. So Raiden, do you see how this triangle AKN is the same as the
Yeah.
triangle JAK? Because those two
Yes.
triangles all have the same sides, right? This side is the same as this. This side's the same as this, and the third side that they both share, which is why we use the reflexive property, being like, okay, well, this side in the triangle is equal to this side in the triangle. Because they're all the same, now you can say, okay, cool, triangle JAK, triangle Jack is congruent to triangle ANK.
Yeah.
Okay? So this triangle is congruent to this triangle. All right, and now this is where like the final thing comes, where we're trying to prove, again, like it's always good to figure out like, wait, what the fuck was I actually trying to do, right? We're trying to prove that angle JKA is equal to angle NKA, right? We're trying to prove that this angle, right, is congruent to this angle. And it turns out, because this is the five letter thing you probably were trying to remember, CPCTC. Do you know what CPCTC stands for?
Yes.
What does it stand for?
Corresponding parts of a congruent triangle are congruent.
Good, very good. Yes. Good. Corresponding parts of congruent triangles are congruent. What that basically means is that if you have two triangles and they're the same, basically if you have two triangles and those triangles are congruent, then the parts of those triangles, the corresponding parts of those triangles, are also congruent. So you see how this triangle, right, is the congruent to this triangle? And we proved that, right, because all the sides. So the sides of one triangle are equal to the sides of the other triangle. That means also that the corresponding angles of those triangles are the same. So, for instance, this angle on the triangle is the same as this angle on the other triangle. And this angle on this triangle, right, is the same as this angle on this triangle. Because it's the angle that's opposite this side, and this one's the angle that's opposite this side. You know, opposite of the hypotenuses of each one. So, since these two triangles are congruent, right, JAK and ANK, that means that they're corresponding angles, which means the angles that are in the same place on each triangle, those are also congruent. So that's why angle ANK, or AKN, sorry, this one, right? This angle, which is opposite, right? The line segment AN, the two red lines I said, and angle JKA, right, which is also opposite of the two red lines or line segment JA. These angles are now the same, because they're the same angles. They're the same. They're the corresponding means like they're in the same place, right? They're in the same place of two triangles that are congruent, and so that's why you can say your final statement and CPCTC is why it is, and then you're done. It's proven. Did that make sense, Raiden? Did that make more sense? Oh,
Yes.
damn, Nick redeeming all the fucking MT coins. Wow, y'all going real ham on the tournament. Cool, Raiden. Awesome, dude. I'll get you some points for that. Sorry. Add amount. Next question. Well, I gotta go to the next person. So. Raiden, let me answer someone else's question, and then like if I have time, I'll come back and do yours. I gotta make it fair, so it's at least like one question per person. And this looks like.
Yeah, we want to learn too.
Yeah, it's all right. You guys are all good. I appreciate everyone want to learn, and if we have more time, Raiden, I'll come back and do
Yeah, they did substitution like on Monday, and I skipped class on Monday. So.
Okay, why'd you skip class, bro? Don't fucking skip class, dog.
Because I can.
What? No, don't skip class, bro, dude. What? All right.
Yeah, I need help with that.
Okay. All right. Okay. Let's do Mason's question because Mason was next, and then I'll do Patty's, and then I'll do Grimm's, and then Obama. Did you post a question? Oh, Obama just redeemed a bond coin. Okay, nice, Obama. I'll make sure you get your bond coin. Okay, cool.
Do I get a bond coin for that?
For what? You get a bond coin once we do your question. Mason, you here, bro?
Do I get a bond coin for doing here?
Nice, Mason. Okay,
And
cool.
doing a cute emoji?
No, you don't. You don't. Okay. All right, Mason.
did
Let's
a
help
cute
you out here,
emoji.
dude. Oh, show that they're inverse functions. Use a graphing. Okay. Well, that's kind of dumb, but that's okay. Okay. Cool. So let's see. 20. You want 21 and 24. Okay. So they want us to show that these two things are inverses. Let's see. This one. Okay. This is cool. Inverse functions are pretty cool. Mason, do you have an idea of like what inverse functions are?
They're just, aren't they just like, they're not like, okay, yeah, okay, I just remembered. It's like, so let's say it's like, x2 and then like y4. It would make it so x4 is y2.
Good. Yeah. So if you have a function, let's say we have a function, right? F of x, and what they'll usually do is they'll put a -1 up here. This is how they say like inverse function, okay? So if f of 4, for instance, is equal to 2, then the inverse, which is f inverse, right? F -1, the inverse of 2 will be equal to 4. It's like if I put something into a function and I get a value, if I put that value into the inverse, I get the value of the function. But it's like a reverse thing. It's like a backwards, like a that's like my best way to describe it. Yeah. If you take the value of a function, so if we try to evaluate f of 4 and we get 2, then if we took the inverse and evaluated it at 2, we would get 4. They're backwards. Okay. Couple ways to find inverses, right? So the easiest way I find to find inverses is just to switch what the x and the y is and then solve for y again, okay? So let's say we have, so this is what they give us. They give it f of x is equal to the square root of x minus 4, right? So then what I'm going to write is I'm going to say, I'm going to switch this around. So this looks kind of like, right, y is equal to x minus 4. If we just say f of x is equal to y, okay? Now what we're going to do is we're going to switch the x and the y, okay? So we're going to get that x is equal to the square root of y minus 4. So anywhere you see an x, you're going to write a y, and everywhere you see a y, you're going to write an x, okay? And now we're going to solve for y again. So how do I solve for y here, Mason? If I have x is equal to the square root of y minus 4. Mason. There he is. Yeah. So Mason, how do I solve for y here?
So for y, you
Yeah.
would do you would like you would do to the power of 2 and then
Good.
plus
You'd
4.
square both sides. Very good. Very good. So this is x squared. And if I square a square root, what happens when I square a square root?
It cancels out.
Good, good, good. Goes away, right? So this just becomes y minus 4. Okay. So now do you see how I can just add 4, and I get that y is
Yeah.
equal to x squared plus 4, right? So this is now the inverse. So we say f inverse of x is now equal to x squared plus 4. And they said the inverse was equal to g of x, right? So is that what, let's see, is that what's true? Yeah, look, see, x squared plus 4. That's, yeah, okay. So now that's how we found out they were inverse functions. Show that they are inverse functions algebraically. That's a good one. How do you show that something's? I think that is showing algebraically. How did they do it to show it algebraically?
I don't remember exactly, but I'm pretty sure they did it where it's like they take something and they make it so it equals to x. Like they have an equation and then it equals x, and you have to like prove it that.
Oh, okay. I know what they're doing. Okay. Here's another kind of property of inverse functions. So the inverse of the function should equal x. That's always what should happen. Is this what you're talking about, Mason? Have you seen this before?
Probably.
Yeah. You've seen arctangent, right? Have you seen like arctan and stuff? Have you seen
No.
that? No. Have you seen? Oh, wait. What math are you in again, Mason? Sorry.
I'm in algebra 2.
Oh, so you got no. Sorry, this is trig. You haven't done any of this yet. My bad. Okay. All right. This is another cool property of inverse functions is that the inverse of a function is just equal to x, is what it is. So f of -1 in this case they're saying is g of x, right? Like g of x is the inverse of f of x. So
Yeah.
we should be able to say g of f of x should just get us equal to x. And this is called composite functions. Have you done that too? Have you done like a function of a function?
Like composition.
Yes.
Yeah, that's what the we just did was.
Yeah, when you see like the circle that looks like this, for instance. Yeah, good. Okay, yeah. So let's see if that works. So g of f of x. So g of f of x, right? That would be equal to f of x squared plus 4, right? Because it's x squared plus 4. But we're not doing x, right? We're doing f of x, okay? And then f of x happens to be this, right? So this is g of f of x is going to equal to square root of x minus 4, right? All of that squared plus 4, which, right? If you square a square root, we're going to get x minus 4 plus 4. Cancel, cancel. So do you see how this is just equal to x?
Yeah.
Yeah. Does that make sense? Why that is? That's actually kind of a unique thing, honestly.
I'm not really sure.
Yeah. Okay. So
1 second.
what an inverse function does is an inverse like strips away the function to get what the value is, to get the argument. Right. If I have the function of the inverse of a function is always going to equal to x, and then the inverse of a function is also going to equal to x. This is you can kind of think of this like this f inverse thing as like stripping away the function, and it just leaves you with the x. It's kind of like a magic eraser or something.
Okay.
And that has to do with this, right? So let's remember, right? Let's remember that, like, for instance, f of a is equal to b, right? If I just put in a value a and I evaluate the function, I'm going to get b. So if I take the inverse of b, what am I going to get?
Would that just be a?
Good. Yes. That's what you remember from definitions of inverses, right? So now let's look at this, Mason. Let's say I do f inverse of f of a, right? Let's say I inverse both sides, okay?
Yeah.
Do you see how like I applied an inverse to this side and I applied an inverse to this side? Do you see that?
Yeah.
Okay. And let's remember, the inverse of the function, right, just strips away the function. So this is just going to become a. And then this is just, cool, f inverse of b, right? Which is exactly what we said over here. See how these are the same statement?
Yeah.
Okay. Another way to think about inverses, here's a simple way for an inverse. Okay. Let's say we have I don't know, 4x equals 16, right? And I'm trying to get rid of this 4, okay? I'd like to get rid of it. What would you usually do in order to solve for this, to get just x by itself? What would you do?
Divide by 4.
You divide by 4. Okay. Dividing by 4 is the same thing as multiplying by what?
What?
If I divide by
Two.
4, that's the same as multiplying by what?
Oh. I don't know.
Okay, so if I divide by 4, right? Divide by 4 is the same thing as saying times 1/4,
Oh, okay.
right? So here, right? This is us doing the. This is effectively us, right?
Yeah,
Dividing
okay.
by 4 on both sides, right? Okay.
Yeah.
So here's a cool thing. Do you know what the relationship between 1/4 and 4? Do you know like maybe something about them? Like how are they different?
I don't know. They're like, I don't. Well, 1/4 is just like 4-1 flipped.
Flipped. Good. What's the flip called?
Reciprocal.
It's called the reciprocal, but it's also called the inverse. So-
Inverse. Oh, okay.
Like what's 4 to the -1?
Oh, okay.
Do you see this?
Yeah, because if it's a negative exponent, you have to like put it to the
Good,
bottom.
good. And this is literally what an inverse is. Do you see how this inverse kills off this? Do you see how these like these kill each other?
Yeah.
Yes. It's the same thing when we do this. So when I have a function and I multiply it by the inverse, right? Or I this is technically an operator. It's technically what you're doing, but it's the same thing. You're doing something to both sides. That's what it kills off the f is what it does. That's what inverses do. So it's the same thing here with 4 inverse killing off the 4.
Betrayal.
Betrayal. Yeah, that's cool. All right. Does that make more sense about inverses, Mason?
Yeah, it does.
Okay, cool. So here, let's have you do 24, and then. Okay, so then how would you do 24?
So.
They want you to prove that they're algebraically that they're inverses of each other, right?
So saying that f of x is. So it's saying all that is greater than 0, and the other one is in between 0 and.
Yeah. So these are domain restrictions. Okay.
Oh, okay, yeah. So that's like what you can't.
Yeah. Don't worry
That's
about
what
these.
X
Yeah.
can't do.
Yeah. Don't worry too much about these. The reason why these are domain restrictions, right, is because, for instance, I can't have 0 here, right? If I put 0 in for x, I start getting divide by 0, so this is bad. It's the same reason up here we had a domain restriction. Do you see x had to be greater than 0?
Yeah. Okay.
Right. Well,
So,
yeah. Actually, I think
I
x
forgot
would
how
have to be
you-
greater
I
than
forgot how you
4.
set it up.
Okay, so let's remember to prove something algebraically is an inverse, right? So if to prove that two things are an inverse of each other, right? We know that f of f inverse, right, has to equal to what?
That'd be the g of x.
No. Well, f
no,
inverse is
that-
g of x, right? You're right.
Oh.
This is g of x. Right.
Yeah, so that's g of x. So.
But what happens? Let's remember, Mason, back to here, right? What happens when I take the function of an inverse?
Just like cancels out.
Cancels it out, and so what do I get? I just get.
Oh, so that's just x then.
You just get x, right? It's the
Okay.
same. It's the same thing we did here, right? When I took the inverse of the whatever, like I just
Yeah.
got x, right? So here we can show that the function, the composition of the function with the inverse has to equal what?
X.
X. Good. You just need to prove this. Is all you have to do. Okay. How can I prove that with this?
Okay, so you have to put. So you would have to replace all the x's in f of x with
Yes. Good.
the g of x, and then have it equal to x.
Perfect, dude. Yes. Okay. So and this is this is a little bit complicated, right? Because g of x is
know,
like 1 minus x over x, right?
I remember. Yeah, I remember doing this stuff in class. It's just annoying.
Yeah, I know this is a huge bitch. Okay, so I have to prove this is equal to x. So actually, a cool thing to do here, Mason, is whenever I see like shit like on the bottom here that I don't like, I'm just gonna multiply through on both sides by x. Okay, so the top and the bottom. You're always allowed in algebra to do stuff as long as you do it to the top and the bottom, or you do it to both sides, right?
Yeah.
So in doing that, right, this is gonna turn into x. What is the bottom gonna turn into?
Just 1 plus 1 minus x.
No, it's gonna turn into x
Oh, okay. X
plus 1 minus x, right? Because this don't forget, you have to multiply everything by x. So this is going to turn into x, right? And then this is going to cancel with this one, right? Okay. So now what do I have? So I have, right? Do you see how x and I have minus x?
Yeah.
What's that going to do?
That's just gonna be x over 1.
Good. This is going to go away. Good. You just have x over 1, which is equal to x, right? Equals x, QED. Like, you did it. Right?
Yeah.
Cool. Nice. They would like you to graph them. So you can graph these two functions separately, and they say to describe the relationship. So here's the relationship between inverse functions of graphs. Let's say you have a function that looks something like this. Something like this. Well, like this, right? The inverse function is always going to look like the reflection of it, okay?
Yeah.
But it's going to look like well, if I could draw a reflection, Jesus, like, okay. my drawing skills are not the best today. Okay. It's always going to look like it's going to look like a mirror image of it across the line y equals x. That's what an inverse looks like, for instance. So if this is going to be f inverse of x, and this is going to be f of x.
Okay.
Cool.
Yeah.
Nice.
That helps.
Okay, awesome. Yeah, does that make more sense to you?
Yeah.
Nice, dude. Good. Awesome. Congratulations to Mason for learning. That's cool. Yeah, I like you always have good questions, Mason. I like having to remember this shit, you know. Just like, oh, what is this? Okay, nice. Good. Bond coin for you. Let's see. Who else? You don't deserve to learn. Raiden, don't say that, dude. Who's next? Patty Graps. You hear Patty?
Yes, sir.
Ooh, I
Oh
like
my
that, dude. We
God.
got the music going, dude. What's going on, dude? You trying to serenade me?
That's my mom's ringtone.
What? It's like some
yeah, it's
ethereal
really
ass
annoying.
shit, dude. What the fuck?
It is really
grab your
long. It
patty?
gets really annoying.
Can
Yeah.
I grab your patty?
No. Graham, gotta chill, dude.
Okay, so
Oh, so you're doing composite
basically my
functions too. Here we go. Yes, composite
yes.
functions.
Okay, but here's the thing.
Here's the
So
kicker.
I
He
haven't
says.
been
This
in
is less
school.
readable, man.
I haven't been in school this whole
All
week
right, thanks, Mason. Yeah.
because I'm out of town.
Oh, you're in
so-
Poland.
Yes, sir.
Fuck. What time is it over in Poland right now, dude?
It is. Hold on. It's 11:34.
Dude, that's sick, dude. Look at this, dude. Actual education has gone international, bro. We're international.
For real.
We're
Patrick,
international.
when do you get back from Poland?
I'm gonna be. I'm gonna be home Saturday.
Oh, okay.
We will take over the world soon.
We will take over the
Yeah.
world soon. Yes. Okay. Cool. All right. Okay. So you haven't really been in class, so you need some help. Okay. What do you need help
Yes.
with all these?
I mean, okay. So I looked at the last stream.
Oh, good. Good. Yeah.
Because I saw Philip like putting stuff into the
Good.
office hours
Good.
chat. So I watched you answering his question,
Nice.
and it did help me a little bit.
Good.
But yeah, still some things that I still need to like
Sure. That's totally okay.
understand.
That's awesome that you went back. See that I love that. That's what being proactive is. Is like, you know, I already taught this, and you're like, oh, let me go like watch like how he actually taught it to someone already. Yes. Love that.
Mhm.
Okay. So which ones do you need help with? Is this 69 the first one? Is that the one?
Yeah, the ones that are circled are pretty much the ones those are the ones that are for homework.
Okay.
So
But you'd like to like kind of understand like how to do them anyways. That's totally
yes.
cool. All right, cool. All right, so we have F composite G of 3. Okay, cool. So this like circle-y thing right here, right? All this means is this means f of g of 3 is what it means. When you have
Yeah.
So what it means is like I'm gonna evaluate f at a certain value, and the value I'm gonna evaluate it at is the value of g evaluated at 3. It's kind of like a inception thing where like you go in and whatnot, right? So the first thing you have to figure out is like what is g of 3, okay?
Yeah.
And so they give you two graphs here, right? They give you f of x and they give you g of x. So how can I figure out what g of 3 is?
Figuring out what g of 3 is.
Yeah. This is what we need. We need g of 3, right? What's g of 3?
Okay, well I can see that g of x is a
Good.
linear function.
Good. It's this nice graph here, right? Yeah.
And I can see that it's intersecting 4 at both y and x.
Good. You can. Yes, you can see that too.
Does the slope really matter in this?
It could if you wanted to get the equation of it, but like it's pretty simple here. So you don't need to make it too difficult. Like it's simpler than it seems. So g of 3, right, means what is the value of g at x equals 3, right? That's what it means for g of 3,
okay.
right? Or so here they're saying y is equal to g of x, right? So y equals g of 3 is just saying, okay, what's the value of y when x is equal to 3? So when x...
It's 1.
Good, it's 1, right? So g of 3 here is equal to 1, right? Because you went here. You did this, right? You're like, okay, cool. At 3, it's equal to 1. Okay, so now instead of g of 3, right, I can write this as, okay, what is now f of 1, right? Because that's what g of 3 is. G of 3 was 1. So now I'm going, okay, what's f of 1? So using that same strat that we did here for g of x, how can I figure out what f of x is at 1?
Okay, so f at x equals 1. It would be y equals 2.
Good, yes.
Yeah.
So this would equal to 2. What's up, Jack?
After that, don't play some Warzone together because I couldn't play.
Yeah, dude, I'll play 1 or 2 games of Warzone after office hours. Cool. All right, just hop on in like 20 minutes, dude. I'll be on. All right, yeah. So Philip, do you see how this answer is then going to be equal to 2, right?
Yeah, but also my name's not Philip.
Sorry, fucking Patty, dude. He's like, dude, you know what's the worst, dude? I was tutoring some kid yesterday, and I kept calling him the wrong name because usually when I tutor people one-on-one, I can see their face, and that's like how I recognize like names and whatnot. But this kid, for some reason, will never show me his face on his webcam, and I'm just like, what? Like, your mom's paying me like $120 an hour, like you won't show your face? I'm confused. So I kept calling this kid the wrong person, and I'm just like, damn it, man, dude, like, and I can't do the faces. And also because I associate you and Philip are both all. Do you, Philip, and Mason all go to the same school?
Yes.
Oh, that's so cool. I got 3 students from the same school. That's fucking sick. Okay.
Well, Nolan also goes to our school.
He does. Nolan's in a different math level, though.
In a different class, though, yeah.
Yeah, Nolan's doing geometry, though, right? Okay, that's super cool. Wow, I got 4 students from the same high school. And it's somewhere random in, like, Philly, right? Or, sorry, Chicago.
Illinois.
That's right.
Chicago.
That's where you guys are, yeah. Okay, cool. All right, Patty, do you see why this is equal to 2, though?
Wait, okay, so g of 3 equals 1.
Good.
So then, okay. And then the f is on the outside, and you're basically the function of, I don't even know what I'm trying to say, but I understand why.
F of 1 is what you're saying. You're saying, okay, then f of 1 is equal to...
F of 1 is basically f of 1 is basically f of g of 3,
Good,
which
yes.
equals 1. So
g of 3 equals 1. So f of 1 is equal to...
Yeah.
Is equal to 2. Equal to 2. That's where this is all coming in from. So, again, f, this whole f composite g thing, right? This is f of g of 3. G of 3, we figured out, was 1. So now it's f of 1. And f of 1, right here, is equal to 2.
Yeah,
So that's why this whole thing is equal to 2.
I got that.
Okay. Could you do this one? Could you do 70?
Okay, I'll just write it down real quick. F of G. Wait, what is that? 1?
Mm-hmm.
Okay. So, using the graph. Okay, so
let's remember again.
it would be
Mhm.
G of 1, right?
Good. Yes, g of 1.
G of 1 equals 3.
Good.
So, what the? My mom's phone can't shut up today.
Dude, that's a different ringtone, though.
That's call. That's a call.
Oh, wow, dude. What is that?
I'm
Is
gonna
that,
turn it off.
is that Old Town
Oh my
Road or
God.
something?
I think no, it's not Old Town Road. That's Lil Nas X.
Oh, okay.
Okay. So then
It's good. So G.
F of 1.
So
right?
it's not f of 1, right? Because you found g of
Wait.
1 was equal to what?
3.
Good. So now I'm doing f
So
of
it
what?
would be F of 3.
Good. F of 3.
Okay. So then F of 3 is 2.
Good. Yes. So the whole answer is just
Okay.
2. Okay. So now let's switch things up. Okay. Now let's do this. Let's do 69 part B.
All right, hold on. Let me erase this.
Mm-hmm.
So I'm doing this basically on the same sheet that my homework is on.
Oh,
so.
okay.
So 69 part B.
I assume they're making you do A and B, right, for 69, if they label it like that.
I think it said only part A.
Okay.
but
Well, I want you to do
Yeah,
part B to
it's
see if you understand
69A
it.
for some reason.
I don't know. They're weird as fuck.
They're weird as
sometimes.
fuck.
My sleep schedule is completely fucked now.
Oh, I bet, dude.
I've been going to sleep at like 2 a.m. here. And
Yeah.
For you guys, or no, for my time, it would be. Hold on, it's 6 hours ahead. So, what is that? 9.
Yeah, you're going to bed at 9. So you're going to bed. So when you come back, you're going to be going to bed super early and rested.
Yeah, but I generally do stay up till like 12 at my place.
Sure.
So
You're gonna have to shift it.
Okay.
Hey, I'm your favorite one, right?
Grim, what do you mean your favorite one, dude? What? I didn't say any favorite
What?
people.
I'm everyone's favorite.
You are everyone's favorite. Okay. All right, Patty. So let's try to do part B here.
yeah. Okay. So start off with F this time because it's the second.
Good. You see how it's flipped, right? G composite F is G of F of 2.
Yeah.
Okay.
Okay. So F of 2
Mm-hmm.
is just 0.
Go ahead.
So then G of 0
Mm-hmm.
equals 4.
Nice, dude. Okay, cool. You got it. Yeah.
I got it, bro.
You understand it. You understand it,
got
bro. Okay. Okay.
I got it.
Okay, but then this is kind of the harder ones right here. 73 and whatnot.
Oh, that's the thing that Philip went over with you. I did that.
Okay, that makes sense to you. Good. Okay, very good. Yeah.
Hold on. Yeah.
That's the whole like you're building the house.
Just to make sure that it's correct.
Good. Yeah.
F of x is the cube root of x.
Good. Very good.
And then g of x is x squared minus 4.
Yeah. Good.
Oh, perfect.
Because what happens is like f of g of x, right? You just slam this bitch into here.
Yeah. G of x goes into the where x is.
Good. Yes.
Yeah.
Very good. Okay. Cool.
Okay.
All right.
What's the next one then?
Yeah, I think you had.
What was my next one?
I think it was 41 coming.
I
up here.
also put in another page, but that's later.
Oh, okay.
In the thing.
Let me see. Oh, I see. One sec. Yeah. Okay, I see.
Oh, yeah.
That's that
okay.
page, but let me pull this one in.
Yep.
Okay. Graphing the sum of two functions. Oh, gross.
Yeah, I don't know. This one, I started my homework and I'm like, what is this?
Okay. I don't know why you would need to do this, but okay. Graphing the sum of two functions, right? It just means you're adding up the values, right? So h of x is this new function, which is this function plus this function. which just means
Yep.
for every x value, you're just going to add up what the y values are. So let's look here, for instance, right? What's the y value for g?
Y value for G is -1.
Right. What's the value for f?
2.
2. So what's the sum of those two?
1.
Right. Cool. You see how this is going to be like here, right?
Mm-hmm.
And then this, right, is going to probably, right, this is 3 plus 0. So this is just going to be up here.
Yep.
This is 1 plus, it looks like a half. So I don't know. It's going to be like something up here. And then again, this is 3 plus 0. So it's just going to be like this. So it looks something like this. This is dumb. I don't know why they really have you do this, but.
Wait, so basically all we have to do is graph it, or what?
Yeah, I think so. Yeah.
Oh my god, that's annoying.
Yeah, they just want you to graph. And what you do is you're basically going to every x point and you're summing the two y points is what you're doing.
Gotcha.
The reason why you would do this, for instance, let's say, for instance, this was like, I don't know, like the amount of kills that like each player has in a team, like player F has this many kills, player G has this many kills, and you want a graph of the total amount of kills of the team, then you would be graphing F plus G. I know you can't have negative kills, but maybe like the guy just suicided a bunch of times, but
suicide, yeah, dropping that KD on purpose.
Well, suicides like usually count as like negative kills usually when you play games, I think, right?
Something along those lines.
Yeah. So
shut up, mom's phone. Holy crap.
So yeah, that's an example of real world example of why you would add two graphs together. Yeah.
Gotcha. All right, I'm just in the middle of drawing this, so
yeah, you're good.
No. Three, two. All right, this is kind of slow. Whatever. All right. Now I'm actually graphing the sum.
Right. Yeah. It's just dot.
Okay, so 2 minus 1, 1, obviously. 3 zeros, so it's just up here. The half thing.
There's like 1.5.
So that's just half and 1. So no wait.
It's 1.5, I think. Yeah.
Sum of them. Yeah. So it's somewhere like right here, and then that one stays the same.
Yeah. Good.
Okay, got it.
Okay. So now they want arithmetic combinations of functions. These are kind of cool.
Okay. I think I did try to get started on this. I have something for this. Okay. So for the first one, it's adding them.
Yes.
So what I did was I did 2x plus 5 plus x squared minus 9.
Good.
I don't know if that's
right.
though.
That is right. Yeah.
And then it comes out to be x squared plus 2x minus 14.
Minus.
And I don't think.
Wait. No, it's not minus 14.
Factor that.
It's not minus 14. It's minus 4. Because you have plus 5 and minus 9.
Wait. Oh, I wrote it wrong. I'm an idiot. Okay. I wrote minus 5 instead of plus 5. That's my bad.
It's all good. Yeah, and I don't think you can't really factor this.
Yeah, plus 4. Yeah, you can't really factor that. Okay, and then the next one. Okay, I messed this up again. It's another minus. So I gotta redo this. Okay, just give me a second. Just gotta erase all my work here because of that one little minus sign. Okay. So 2x plus 5. So it's just the same thing.
You're just subtracting them instead.
Just the x squared is negative. Right? And then do you have to factor out the negative or?
No, I mean you can just leave it how it is. So we could do 2x plus 5 minus x squared plus 9. Right?
Yeah.
So that's just negative x squared plus 2x
plus 2x
plus 14
plus 4
plus 14, I think. Because this minus is going to make this a positive. Because it's f minus g.
Wait, what?
Hold on. F minus g, right? So this is going to be negative x squared plus 9 if you're doing subtracting g.
Oh, okay, gotcha.
It's okay.
So-
It's late in Poland.
It is a little late. Plus 14. Okay.
Yeah, good.
And then just leave it like that because you can't
Just
really do
yeah, you
much
can't
with
really
that.
factor it. No, that's fine. Okay, next one's kind of tricky though. This is FG. What does it mean? What does it mean for it to be FG?
FG. I don't know. I think I did the composite thing.
No, so that would be F circle G. That would be composite.
Yeah.
This
I
just
know.
means multiplying them together is what it means.
Okay, so hold on. I'm gonna erase this because I did composite.
Mm-hmm.
So, what is it again? 2x. So it's 2x plus 5 times x squared minus 9.
Perfect. Yes.
Okay, so the x squared minus 9 I know can be factored.
It can, but you don't want to do that because
Why not?
Because then you're gonna have more things that you have to multiply by, right? Does it make sense? Like
Whoa.
I think you just want to foil these two things.
Wait, so are we just
Distributing it.
or
Yes.
not distributing?
Yeah, distributing is what it's called.
Distributing. Okay. I don't know. I just have different names for different things.
It's all good. Yeah, math is
So 2x squared.
Uh-huh.
So what is that? 2x cubed.
2x cubed. Good.
Okay, so 2x cubed. And then 2x. That would just be negative 18x.
Good.
And then it would be plus 5x squared
Good.
minus 45.
Perfect, dude. Nice.
All right, so just to rearrange the numbers.
Yeah, you can just put them in like
Plus 5x squared minus 18x minus 45.
cool.
What can we do with that?
That's just what it is. That's what it is.
Straight up what it is.
They're just asking you just to make it how it is. Yeah. This is me the interesting one when we do F over G, right?
Okay. Hold on. So my pen is being really weird. Like it's been like this for like the past 2 weeks. It's been like okay. So I'm trying to make the box right now, but sometimes like my pen just like stops working for a second and then starts working again. So it makes like dotted boxes and it's really annoying. I don't know.
Have you tried? Sometimes it has to do with the angle that you're writing. Sometimes like if you write it in a circle because it's whatever the ball point is on the top is getting like stuck.
Oh, I probably shouldn't have bit it like 100 times.
Yeah, that's true. Yeah, don't bite your pens and pencils. Don't do it.
Yeah, learning that now. Okay, and we also have to find the domain of f of g. So
F divided by G, and the reason why, because F divided by G, right? So if this one is
that's what I
if
meant.
this is them multiplying by each other, what is this? What is this going to be?
What?
If this is if F G is F times G, what is F divided by G, right? That's what part.
Yeah, so it's going to be 2x plus 5 over x squared minus 9.
Good, x squared minus 9, right, good. That's just what this is.
Yeah.
Right.
Mm-hmm.
Now they're asking for the domain, right? So what does the domain mean?
What?
What does the domain mean? What does it mean to find the domain of something?
Okay, so the domain is like... it's like negative infinity and positive infinity, and sometimes there's like restrictions or whatever.
Good. Why? When are there restrictions?
When division, the denominator has a 0.
Good. Yes, dividing by 0 or square roots of negative numbers, or when you you have things that you can't really do. That's when you have restrictions on the domain. Domain tells you like what values can I throw in for x, and so if you the restrict. So what's the restriction here? Like what's the restriction on this one?
Okay. Well, to find the restriction better, couldn't you just do it like factor it out, or does it really?
You can. Matter? Yeah. No, you could. That does help. So 2x plus 5, right? Good. And what would this factor out to be?
Yeah, because it's gonna be x plus 3 and x minus 3.
Perfect. Good. Yeah. Nice, dude. Nice.
So you know that it's gonna be negative 3 and positive 3.
Good.
That can't be.
Exactly. So you're gonna write domain is gonna be all real numbers. This is how you write all real numbers.
Yeah, I know that symbol.
And then you say except, and then you say like x cannot equal 3, x cannot equal negative 3.
Okay. Well, I wrote it like this because that's what it was like on the notes. It was negative infinity to -3 in union with -3 to 3,
Yes.
and then in union with 3 to positive infinity.
That's another way to write it. Yeah, you can totally write it. Yeah,
Yeah.
from negative infinity to.
Okay, so I wrote it like that, but it's pretty much the same thing.
It's the same thing. It's the same thing. Math has a bunch of different like languages on like how you can do stuff.
Yes, it does, and I hate it for that.
Yeah, I know. They make all sorts of things. Nice. Does that make more sense to you, Patty?
Yes.
Dope.
This is helping me a lot more than a video just explaining.
Dude, yeah, well, dude, Philip was telling me that like there was some video that.
Yeah, you guys were talking about it on that stream when I was watching it. I was like.
He's like, do you want me to send it to you? I was like, no, it's probably fucking garbage, dude. I don't want to fucking look at it.
Philip said like he just gave up his job for a week.
Oh no, dude.
And I literally said the same thing the other day. Yeah. I'm like, I told this to my mom because I was like so pissed about like how the fact I didn't know anything about this. And I told her that like the teacher is just giving us videos and smacking it in our face and trying to make us do homework on it.
That's so lazy, dude. I don't know. Teachers are.
It is, yeah. And it really makes me mad.
You're like, I don't like it. All right, let's see.
No.
Grim, I got time. Grim, I got time to do your question real quick. Is that cool, Grim?
Finally.
I know, finally.
Oh my.
Okay, good.
Okay,
Patty.
I guess.
Yeah, you can work on the next page. If you still get stuck, you can ask me tomorrow during office hours. Or wait.
Yeah. I got you.
Maybe I'll do a Friday stream as well. I usually only do Monday through Thursday, but I know I was kind of out this week with LASIK shit, so maybe I'll do another one tomorrow.
All right. Yeah, I got you.
Cool.
I do the other ones.
Yeah.
Thanks for the help.
You're very welcome, dude. Thanks for coming by. Good questions and stuff. Here's your bond coins. And
yes, sir.
Yes, sir. All right, dope. All right, Grim, dude. I got 5 minutes, dude. Let's teach you some substitution. Cool.
Okay.
You ready? What do you mean, okay, dude? You sound so sad, bro. What?
Because he took too long.
He took too long? No, he didn't take too long. I just had to. I got to teach things completely to someone. I can't just like let him just bail. Too long would be if I did the third page with him as well.
Right now, explain to me all of Algebra 1 so I can be ahead of my class and skip a grade.
Oh, you can do that for yourself, bro, dude. You just got to go pick up a textbook and just start learning. You know, you don't need me for that.
Gotta teach me.
You don't need
me. I can pay you. You
can pay me? Or you can pay me in Takis?
Yeah, I'll pay you in Takis. 1 Taki per hour.
All right. You're in algebra, right? You're in algebra?
Yeah, Algebra 1.
Okay, cool. All right. Nick's like, yeah, boy. Okay. Okay. Do you want to know why we need to do substitution? Like, what's the point of substitution?
I learned what's it called? I forgot what I learned.
Here,
let's. What it's called. I already learned graphing in the other one.
Okay,
I forgot the other one.
All right, let's say we have an equation here. Okay.
Yeah.
Let's say we have y is equal to x squared plus 2.
Substitution?
Yes.
I'm pretty sure substitution is like when you don't have the same things that can cancel out each other, so you multiply it by something.
Oh.
What's up, Jack?
Is that right?
Kind of. Jack, give me 5 minutes. Let me teach Grim real quick.
If what I said is right, instead of substitution, can you teach me the next step of algebra, like what's gonna happen after?
Well, here, Grim, I want you to answer this question. If I have y equals x squared plus 2, and I say as x is equal to 3, what is y equal to?
You forgot the second equation.
No. Oh, okay. No. We'll get to that. This is simple substitution. I said y equals x squared plus 2, x equals 3. What is y equal to?
Y equals to what? Let me see. Again to cancel. Let's try canceling it out by 3. Multiply the x. Oh, actually no. I actually don't know that. Wow.
Nick's got it.
11. Let me see. How did 11?
Okay, so this is called substitution. So substitution means, see how there's an x here, and I said x was equal to 3? So anywhere I see x, I'm going to plug in 3. I'm going to substitute it in, okay?
Oh!
So see how this is y is equal to 3 squared plus 2, right? Which is just 9 plus 2.
That'd be 3 times 3, that'd be 9. Yeah, 11.
Nice, good. Awesome.
Oh, then yeah, I failed that exam. I only knew the other two. I didn't know the first
Okay.
one.
Well,
So I failed the exam.
I do have us
I'm trying to learn right now. I'm trying to
Jack,
learn
give me
right
a
now,
second.
Jack.
Jack,
Please.
give me a second, dude. Let me just teach, please. All right.
We'll play later.
No, Jack, I promise I will play with you right after this. But let me just teach this real quick. Okay. So this can get a little bit trickier, Grim. So let's say y is equal to 4x plus 2, okay? But I also tell you that x is equal to y plus 3. Do you know how to solve for this? This is called a systems of equations. There's 2 equations, and there's 2 things you don't know.
Y plus 3.
So I said y is equal to 4x plus 2, but x is equal to y plus 3.
Then that'd be y plus 3, so that'd be like y3. No.
No.
We need like terms.
Let's do I want you to use substitution. Use substitution, bro.
Yeah. Multiply y. That's 4y.
Good.
Plus 12.
Good. So what I'm gonna do here is I'm gonna
Actually,
plug
no.
this thing into here.
Yeah.
Okay. So this is gonna become y is equal to 4, and instead of x, what am I gonna write?
You're gonna write 4y.
No.
Y multiply y by 3.
I'm gonna write
like
y
a
plus
proof,
3.
parentheses.
I'm gonna write y plus 3.
Parentheses.
Good. Make sure there's a parentheses. Good.
Y plus 3.
Very good. Okay. Very important you do the parentheses, because now this 4 is gonna multiply both this and this. Right?
Yeah.
Okay. So what do I get?
You'll get y 4y.
Good.
And 12.
Plus 12. Good. And then what else?
That'd be 14. 4y plus 14.
Good. Now what?
Subtract the 12. Just subtract the 14.
Subtract the
I guess.
14? Yeah, I guess you could. What? So you got y minus 14 equals 4y. Okay. Now what?
Divide the 4y.
No, don't divide it. You see, I still have a y here and I still have a y here. I need y's all to be on one side before I do any dividing.
Oh.
So you're gonna want to subtract y from both sides.
Yeah, subtract y from both sides.
Okay. So what am I left with?
14 equals...
Negative 14 is equal to what?
Negative 14 equals 4.
No. 4y
y.
minus y is what?
4y minus y is 4.
No. What's 4y minus 1y?
3.
3 what?
3y.
3y. Good. Yeah. This minus y doesn't kill off the y. Minus y is the same thing as saying minus 1y. So you have 4y's minus 1y, which is now 3y's. Okay.
Yeah.
Last step. What do I do here?
Next, that's for negative 14 equals 3. You'll subtract them both by 3.
No.
Divide them both by 3.
What are you gonna do? Sorry.
Divide them both by 3.
Good. Exactly. Good. Whatever's happening to the variable, you do the opposite. Yeah, Nick, what don't you understand, dude? What don't you understand? 4y plus 3. Okay. Nick. This 4 needs to multiply by this and this. So it's 4 times y. That's why it's 4y. And then it's 4 times 3. So technically this is 4y plus 12 plus 2. And then Grim just went ahead and he combined the 12 and the 2 to be 14. Nick is what he did. Good. All right, so y is equal to negative 14 over 3. Okay, cool. You figured out what y is, right? But I also need to figure out what x is. How do I figure out what x is?
You plug it in.
Good, exactly. You plug it back into your you can plug it into either one. You can plug it into here, you can plug it into here. This one is easier. Do you see why this one's easier to figure out what x is?
Yeah.
Because I literally just have x equals, right? So now I'm just saying, okay, x equals negative 14 over 3, right? Plus 3. What's negative 14 over 3 plus 3? This is a good, little intro algebra.
Negative 14 over 3 plus 3.
Good, yeah, what's that?
That'd be... I don't know, to be honest. I don't have a calculator with me.
Nah, come on, you gotta do this this is math. You gotta do this in your head.
Like
How do I add 2 fractions together? This is a good review. How do I add 2 fractions?
You make them the same denominator.
Same denominator. How do I make 3 the same denominator as negative 14 over 3?
Divided by 3.
No, you multiply by 3, right? So
Multiply by
3 is the same thing as 9/3, right? Do you know that? 3 is the same thing
Yeah.
as 9 over 3?
Yeah.
Yeah. You see, if I write this as 9/3, I now have negative 14/3 plus 9/3. What's that going to be?
Yeah.
It's going to be what?
Negative. That's gonna be 9/3. What? Oh, the 14. That'd be like about 5.
Negative 5 over 3.
5/3.
Yeah, good.
No, yeah.
Did that make sense? That makes sense, Grim? Why I turned 3 into 9 over 3?
Yeah.
I just multiplied the top and bottom both by 3, right?
Yeah.
9 over 3.
And by the way, if you have, if you have extra time left, can you teach me, well, a little, or like, or some of what I'm gonna learn next?
I don't know
after
exactly
this?
what you're going to learn next, but
Just
how about
like
you
a
ask me
guess
ask me
after,
tomorrow
like,
ask me
when-
tomorrow during office hours. But here, one sec. After 4y goes 4y plus 14. I don't understand, Nick says. Okay. So now you're here, right, Nick? All you got to do is you're solving for y, right? So what Grim did is he moved the 14 over here by subtracting 14 on both sides. You didn't have to do that. In fact, what I would have done, I would have subtracted 4y from both sides is what I would have done. Because, again, the goal in algebra is always to get the variable on the same side, right? So if I move this over, this would have become negative 3y is equal to 14, right? And now I just divide by negative 3, divide by negative 3.
Imagine never getting your points.
You
I
get the
never
same.
got
You
a
get the
point.
same answer, dude. I'm gonna give you your coins, dog. Give me a second, bro, dude.
No, like my channel points.
You don't get your channel points? Why not?
I don't know. I still have 200.
Oh, are you watching the stream?
Yeah.
Maybe it's a lag. Maybe it's a latency thing. I don't know. Why is your name Yang6623? By the way, bro, what did you do changing your name?
I was gonna do it with Ronru, who made it Yin. I wanted to do Yang with him.
Oh,
Yeah.
that's cool.
He betrayed me.
All right, cool. Does that make more sense to you, Grim? Do you understand substitution a little bit now?
Yeah.
Nice. Okay, Nick, does that make sense to you too, Nick? Do you understand that? Just let me know in the chat. Okay. Yeah, you're welcome, Nick. Good. All right, cool. That's all for office hours today. Thank you everyone for joining. Hope you guys learned a little bit about math, science, had some fun. I will announce what we're gonna do this weekend with the monthly tournament. I know I've been slacking on like actually getting that finalized.
Yeah, you've been slacking.
I've
You've
had-
been lacking goals.
I've been having a lot on my plate, you know. So I'm
How about you make me the manager of tournaments?
dude, the amount of like drama, Grim, you cause with other people in the tournaments, dude. I had like 3 different people message me saying that you were like pissing them off, and I'm just like,
How?
Grim is
Was it
fine.
one of them Mark?
Yeah, did they? I don't
Was
know.
one of them Mark?
No, I'm not gonna say who it was, but it's just like
Imagine getting pissed off just because I offered my idea. About
I
how,
know,
like, the tournament should
Grim.
go.
It's okay, Grim. It's okay. It's okay. It's okay. It's okay. It's okay. At the end of the day, the whole thing is, you know, you guys are allowed to say whatever you want, as long as it's nice, right? And you can come up with ideas of what you think. I love the
was just
suggestions.
thinking
I always like the suggestions for what you guys want the tournament to be, because again, I do this for you guys.
Mark wanted to make it a week long or something.
Well,
everyone was
I
saying-
agree.
I was
Well, I don't want to make it winner takes all, because like you guys have been working hard, you know, being in the channel,
I-
redeeming
And I
points
don't
and
wanna-
stuff.
And they're saying they were saying that I'm trying to kick mechanical out, even though I'm just trying to find the fastest way to end.
Gold.
What's up, Jack?
Gold.
Yeah, what's up, bro?
Are we playing?
Yeah, we're gonna play right now.
Not
All right, cool. All right, I'll talk about the tournament more in the Discord. But I'm gonna go play. So okay, cool.
Permanent. Whoa.
We'll talk about it. We'll talk about it. Good to see you guys on the stream. I'll probably do another office hours tomorrow, because I know I think I missed one on Monday because of my surgery. So I'll do one for you guys on
Hey.
Friday.
Gold is playing.
We'll see you then.